coin transactions, there are transaction outputs, and outputs have locking scripts that lock up coins. sCrypt contracts essentially are another way to create a very advanced locking script in an output, which define a lot of complicated constraints under which outputs can be spent, including, for example, the transaction must contain other outputs, or it must have a certain lock time, or a certain amount of time must have passed, or you can also have different options. So you could say, well, there's different ways this output could be redeemed, different paths to redeem it.
Right.
And all of that is essentially a way of creating an output script. Similar to push drop, for example, where in push drop you have a way to push drop.create, and that's how you create an output script. And then in push drop, you have push drop.redeem, which is how you actually unlock. And in sCrypt, you have essentially similar functionality. So sCrypt TS uses smart contract as a base class, and every smart contract that has a locking script it creates, or a way to unlock itself, is derived from that base class. Contracts are set up in a project, which can contain other things, but there are a few notable things in every sCrypt-based project. Firstly, there's a folder called artifacts, which essentially contains all the compiled code that is produced whenever an sCrypt contract is included in a project. And we'll need that, and I'll show how it works.
Is that automatically generated when it's compiled?
Yes, it generates an artifacts folder, and that is it's in the same level as src or public or anything like that.
Okay.
The other thing that is common to all sCrypt contracts is that there's an src folder, and then inside there's a contracts folder, which contains the actual sCrypt TS TypeScript contract code.
Is it required that it's under the contracts folder?
Yes.
Yeah.
src contracts. Always compiles to artifacts, always starts in src contracts. So pretty standard. And then inside of here, we have a file. This file can only import things from sCrypt TS. It cannot import things from other places, or if you do, I would not recommend it at all. So it's very, very specialized. You have to think of this as a very specialized, slimmed down version of TypeScript that not all JavaScript will, not all TS, not all valid TypeScript code will run in this context. So for example,
because it's a subset, right? So all TypeScript code is valid TypeScript code, but not all valid TypeScript code is valid sCrypt code.
That is correct. So actually, that's correct. Well, for the intents and purposes, what happens under the hood is that actually it gets translated to another language called sCrypt. So .script files are like a lower level thing. So I can't say all sCrypt is valid TypeScript, but all sCrypt TS, which is the higher level sCrypt version that we're using, is valid TypeScript. So that a contracts folder can only import things from the sCrypt TS library, and then it can only export a single default class, and that class that it exports, which is the only thing it can export, must extend the smart contract base class.
Yeah.
You cannot export anything else, and it must be the first and only export. You may only import things from this. There are no global variables allowed. There are no process.env, and I'll get into other restrictions. You must export something that extends that smart contract base class. The next concept is called TypeScript Decorators. So TypeScript has a thing called decorators that are where you add an @ so like @ prop or @ method or @ something. That's a decorator, and so these are used to denote particular properties in contracts or particular methods. So there's a thing called prop that you can import from sCrypt whenever you want to add a public property to your class, right? So kind of like to use a decorator that is called prop, and you need to decorate your prop with that. It takes a Boolean, which is true or false. The Boolean indicates whether the prop is a stateful prop. So you can see that you got a state, and you usually want to set that to true if you're using a stateful contract. And we'll get into stateful versus non-stateful contracts eventually. But so you can either say at prop with non-stateful like this, and you don't have to pass anything, or you can say prop true for stateful. So a stateful property is one that is required to be, or that is like a stateful contract, I guess, is a contract that can survive longer than one transaction. So transaction A creates the contract, transaction B must propagate forward the state into a new UTXO, and transaction C can then spend the output created by transaction B. Does that make sense?
Mm-hmm.
Okay, so that's what a stateful contract is. A non-stateful contract would be just transaction A creates the contract, transaction B would be able to update it with a new. It would be able to just redeem it, right? Create redeem is just one-off transaction, non-stateful. So if you want your properties to survive a stateful contract, in a stateful context to the next UTXO, meaning their value must be unchanged, or their value must be subject to whatever you're asserting, you want to pass it as a stateful. If you're just doing a one-off contract, you don't have to pass that. So
it's initialized on the creation.
Yeah.
It could be transformed potentially its value by the contract, and then in the next UTXO, that would have its current state from whatever transformation happened.
Yes, and the contract could enforce certain transformations, but if you pass it to false, then the contract wouldn't even care.
Okay.
So that's the difference. Is if you pass true, it's going to enforce that it is consistent, or that it is as transformed by the redeem function.
Mm-hmm.
So
is there such a thing as private properties?
No. Everything is public. Private is not part of it because everything's on chain. Everything's public when you put it into a contract. So if you want something private, you should encrypt it and store it off chain or something.
So there'd be no point in making some property that's on the class, but it doesn't have the app prompt.
No, you would never do that. In fact, I believe you cannot do that, or if you can, it would be undefined behavior. So you have to decorate every single thing you do in this class with the prop or method. So you can see I've got a few types here. You have like hash or SHA-256 type, big int type, public key type. These are all types that can be used in a contract. This example is the coin flip contract, which I'll run through, and by the end we'll understand how this particular contract works. You can see all of these are stateful properties, meaning I care about all of them during the time when this contract is being executed. So we got, in this case, an Alice hash, we got timeout, we got a Alice public key, Bob public key, we got a Bob number, and we got a state for the contract. So we got 1 or 0, meaning offered, being so to create a instance of this contract, we need to obviously get an unlocking rate. So we need to get a locking script, which we're going to affix to a particular output, right? So the constructor is how you start that, right? To actually get a locking script for your contract based on what you set up, you're going to call the constructor of your class. So you'll say new coin flip contract, and you'll pass in these values into your constructor. So the constructor values, for example, are here. You call your super constructor with all the arguments,
right,
and then you assign your variables. So as you construct it, right? So you have to pass in to construct one. You have to pass in Alice, Bob, Alice hash, timeout, the current contract state, which defaults to 0, the number from Bob, and that's what you have.
With contract state, is there any reason you can't use Boolean? Does everything have to be an integer?
You probably could use a Boolean. I don't know. I bet you could probably, let me check. Can you import Boolean from here? Maybe there's a thing called bool or something. I don't know. I think
Okay.
big int is the main one that people use. Although, is this a real thing?
Can you do capital B?
I think this might be. Oh, it has no export of member bool, so. No, I would say an
Okay.
integer is probably the
Yeah.
way to go. Once again, it's low level. You have to keep in mind you're compiling to a fourth language under the hood.
Yeah.
So I'll now get into some of the rules.
Where does arguments come from?
It is a special thing in all JavaScript functions, actually. You have a special variable called arguments. Whenever you're in JavaScript, whatever, it doesn't matter, TypeScript, sCrypt, TS, JavaScript, whatever, whenever you call a function, you can always use the arguments variable to reference an array of all of the arguments passed to that function.
Really?
Regardless of what they are, yes, no matter what. So the most recently called function will always have that, right? Whatever function you're in currently will have that. And so what you're doing .arguments is you're basically saying, I want to take the arguments of this function and pass them in, like, you're spreading them, you're passing them into the superconstructor. I could call the superconstructor manually with all these things in this order, but this is just shorthand, and no matter what the arguments are, I can change them up here,
much better.
and I don't have to put them into the constructor. So we call the superconstructor, and then we assign our class variables. A couple of restrictions. No code in the constructor other than assignments to member variables, and you can do assertions as well. So you can say, like, Bob's number must be 1 or 0. Right? I could actually add that assertion right now, and that would be probably a way to make this contract. So I could say assertions are something that what you do when you
cut out. What did you say?
Oh, I said
Your video
rules about. Hello.
Yes.
Check 1, 2, 3.
Yeah, it's choppy.
Can you hear me?
Yeah. Yes, I can hear you.
Okay.
Is it choppy for you too, Bob?
Yeah, it's choppy.
For
Hello.
the most part, I was here.
1, 2, 3, 4, 5, 6.
Yeah, it's okay now. For the most part, I can understand what you're communicating, but every once in a while, like, it cuts out.
Yeah.
I'm going to turn off my video then. Will you guys turn off your video?
Sure.
All right. We're audio only, and we have the screen share, and I hope that's good.
Okay.
Yeah.
Okay. Where was I?
Something about asserting in the constructor.
You were going to assert that Bob number.
Yeah. I was laying out some restrictions. So no code other than assignments and assertions in the constructor. Most of what you're doing when you write a smart contract is you're writing assertions, and you're saying this must be true, and then those get checked off. In fact, the every public function of a smart contract must, and we'll get into what that is later, must end with an assertion. Meaning you should just be checking what things are and making sure that they're true using the assert function, and that's it. In the constructor specifically, there can be no other thing aside from assignments and assertions. I can, for example, assert, and the way you write an assertion is you say assert, and it's a function that you import from sCrypt TS, and you pass in an expression which evaluates true or false. So I could say Bob number equals 0n, or Bob number equals 1n, and I could say you pass in like an error message if this is false. So you could say, Bob number must be 0 or 1. In fact, I'll leave this here because it's good. So you write assertions in smart contracts, and then you write assignments. So I used 0n and 1n, and if you don't know, big numbers like big ints in JavaScript, you can add n to the end, and then it makes it into a big int versus a normal int. And we use only big int in sCrypt. You cannot use a number type in JavaScript. You have to use the big int type.
Yeah.
The reason why is because it is more strict. There is no decimals, and you don't want to deal with floating point math. You just don't.
Yep.
Just don't. Don't even. Good luck compiling that down.
Don't go there. Yeah.
So, we're using integers here. That's probably why there's no booleans either. So, we can add assertions, and that's how constructors work. So what you do to get a locking script for your contract output is you call the constructor, and then you can look at the locking script property. So I'll show an example of actually just calling a constructor, getting an output script, so that you can construct an instance of your smart contract. So in operations.ts here, I have an operation called challenge, and
is that a standard operations?
No. This is just what I made, so it doesn't have to be called that. So here you can see I'm actually, let's get into a little bit about importing and using these as well. So when you want to import and use an sCrypt contract in your project, what you need to do is obviously npmi sCrypt ts. That's necessary, right? So how did I set this project up? Well, I set it up normally like a normal React app, and then I went into I installed sCrypt ts in the dependencies. I think it's dev dependency. No, it is actual dependency. So sCrypt ts is installed.
1329.
And then I added a new script called compile. So compile. You just say script CLI C, and that comes with sCrypt. So I added that to package JSON, and that's all I did to really set up sCrypt, right? When I run compile, what it's going to do is it's going to go into the contracts directory of src, and it's going to look at this, and it's going to produce an artifacts directory. So by running that, by dropping this in, and then by running compile, it's going to produce this artifacts. And this is going to come out with a very important file called JSON. So sCrypt, coin flip contract JSON. And this JSON file is basically the output of the compiler. It's it's called an API. Do you guys know what an API is?
Nope.
It's an application binary interface.
Right. Oh yes. This is the one that's a template where you can put in values, isn't it? Yeah.
Yeah. So it's not an API.
Yeah.
It's an ABI.
Yeah. Okay.
Application binary interface.
Now, why?
Common.
Okay, you're only doing it in a single repo now. Before we had to have two repos and then actually copy across.
One repo.
Yeah.
One repo.
Why are we able to do that now, whereas we couldn't before?
Because I figured it out, and I'm going to get to that. But,
right, fine.
We'll lay out the architecture, and that way we can standardize on it and not have to deal with how we got to this point. Because how we got to this point was blood and toil and tears and all those other things.
Yes.
And so you can see this is a bunch of Bitcoin opcodes, and you can see some template variables hydrated in here.
Yeah.
And then we define some descriptors about how this ABI works. But this isn't too important. You just have to know this file exists, and it's going to be important that it does exist, and that we can use it.
Yeah.
So running the compile command will look in sCrypt contracts directory and produce the artifacts directory, which has a JSON file in it. This is the only important file in here unless you're debugging. Sometimes it'll output the transformer for errors. So the compile errors might be found here. You would see, whether it's successful, and if there were any errors, you would see them in this array. So the compiler will produce errors in this format. Otherwise, it'll be there. You also have a transpiled sCrypt. This is low level. You probably don't need this. If you know the old sCrypt language, this is actually how the contract is implemented in terms of sCrypt itself. But you don't have to worry about that because we're using sCrypt TS. You just know that that's what that file is. And then the other file, I guess, is a map. So a source map that just says, all right, well, here's how you map those two things together. So anyways. That is where that comes from. Now, what I was saying is, how do we call a contract, right? So we compiled the contract. Now we know about that JSON file. That's important. We should go and look at operations.ts again. At the very top, I'm importing a few things, some of which I guess I'm not using. But,
right. We used to call that deploy. Is there a reason it's now operations or?
This is specific to this. There's no standard as to what it doesn't really matter what it's called.
Okay.
It's just, I'm going to delete this as well. So, you can see I'm importing the Dependencies, these aren't really necessarily irrelevant. We're importing some SDK things. But then we're importing to-byte string, into byte string, #256, some types from some sCrypt TS, and that's, sometimes useful. I'm importing the actual TypeScript file of the contract from the contracts directory. So I'm just saying, import this contract from this. And then I'm importing the CoinFlip contract JSON file from the artifacts, and you have to do this.
Yep.
So what you're doing is you're actually reaching into the artifacts file, getting the JSON out, and then you have to, before you can actually interact with or use your contract at all, you must hydrate your artifact. If you do not hydrate your artifact, it will not work.
No.
So you need to compile your artifact with the compile command. You then need to import the JSON file as well as the TypeScript file. And then you need to hydrate your JSON into your TypeScript. Otherwise, and that will actually let the system know about that template, that ABI, and make a bunch of magic happen behind the scenes. So this is how you actually import and use an sCrypt contract. It must be done in this order.
Yep.
So that is done, and now we can use this to actually make instances of our contract, and it'll work. So, questions so far?
No.
I don't think so.
No.
Let's
Okay.
proceed to how to actually use it then.
Actually, one quick question. At the top, is that just a type you're importing? Create action result?
Oh, yeah. That's from the SDK TS.
Okay.
That's not directly needed for sCrypt, but it's used in this
Yeah.
context. And I'll run through all of this in more detail. And I hope this is being recorded, because we might even put it up on YouTube. Who knows? So defining some types, blah, blah, blah. All right, so create challenge, right? You pass in, who you're challenging, the amount, the choice that you pick, heads or tails, and then you get a promise for these values. That's like for this particular application. We make a nonce. So Alice makes a nonce based on some web crypto API, random stuff, and then, whatever. And that's using the to-byte string function from sCrypt. So a lot of the time in sCrypt, you're going to use a byte string to represent things, because you have to. And so that's like your main data type in sCrypt is byte string for like just generic data that you want to put in your contract. And so we're producing a byte string, and you can look at to-byte string and other things. At a high level, though, you're making that, setting up all the random numbers. So here's a way to get a big int out of a random number between 0 and 1. This makes a random number 0 or 1.
Yeah.
And we're saying, all right, here's you're converting the integer to a byte string. And you're saying I want to convert it, and there's a length of 1. So you can look at the type signature here. Into byte string takes this, and it took me so long to discover this function existed. It's very useful. And you pass in the length of the byte string that you want.
And that's it.
So
from or imported
sCrypt.
rather.
Yes.
Yes.
sCrypt TS, yeah. They export it and we import it. All right, then you use the SHA-256. You can compute hashes this way. You can do a lot of things. So you compute a hash with the concat of those 2 byte strings. Then you get Alice hex, and you're saying, all right, get public key from Babbage SDK. Who's Alice, right? Bob hex, get public key, and you're doing some key derivation, and you're saying, all right, here's Alice and Bob, at least for this protocol and the way they're interacting. You actually make a public key from the SDK public key. So public key is a type that sCrypt has. If you want to use a public key in your contract, you have to construct it using the public key function, which takes a byte string. And to get a byte string, you have to use the BSV library that was in sCrypt library. So you can import the BSV library from the sCrypt library. See, it's actually imported up here at the top on the end of line 8. sCrypt ships with their own BSV library that has extended functionality, such as bsv.publickey.fromString, and then to byte string. So you can convert a public key directly to a byte string that way. That's how you can use public keys in an sCrypt contract. So you need to know that.
So are you required to use that BSV library?
What is it?
Are you required to use the BSV library?
You have to use the one that's in yes in order to benefit from functions like the to byte string function, which they only have in theirs. So we will need to use sCrypt TS, whatever they support. Xiaowei intends to refactor it to use the new TypeScript library in the future, but that's not yet done.
Okay.
2
So- 2 byte string. 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 2 So if let's say the new TS SDK had a 2-byte string function, would that just work? Or is there something specific to how the sCrypt TS code works?
I believe that they will need to refactor to use arrays of numbers everywhere, and once they do, then everything will just use that. But we'll see how they choose to go about that. That'll be in the future.
Okay.
I don't know if that's specific to how their compiler looks at it. I bet it's something like that. But they will make their compiler work, and we will have to wait for that to know how that's going to work. Right now, we use their BSV library, which is shipped as part of sCrypt TS, and we import that and we use this here.
Yeah. So another quick question is there limitations in this file as far as what you can import? Because I see you're importing like the...
Nope.
Okay.
No.
Cool.
Only in that contract file. Right? The very important thing is in the contract file, there's a lot of limitations, and I'll get to even more of them than I already have as we move forward. But there's 3 lines of code here that have to happen in this order. You have to do this, and then you have to hydrate it. And that's your limitation in this file. You must be able to access that JSON output, and you must be able to hydrate it before you use it. Otherwise, there will be problems. No other limitations. You can do whatever you want in this file because you're not doing it on chain.
Nice.
You're not compiling this to Forth or anything like that.
Yeah.
This is just part of the React app. Like, honestly, this file is just part of a React app. This could be an React component. This could be anywhere. And it doesn't matter. As long as I import this and do this properly, there's no problems.
Okay.
So it's just like I separated this into my own file because I got tired of dealing with Dan's use of hooks everywhere, and I was like, look, I'm just going to abstract this into its own file. But this could have totally been part of a React component or anything else.
Yeah.
So just separated for architecture and convenience. All right. So talking about how to hydrate public keys here, right? You can make a public key like this and use it. I have Alice and I have Bob PK because Bob was actually passed in as a prop up at the top, property line 42. So that was a string, and then we made it into a hex, and then that was the identity key of Bob, which we then turned into Bob's specific key for this protocol, driving a child, and then drive for self. Same thing for Alice, but then I have Bob PK created here. A timeout is created, which is a Unix timestamp, and so that was made out of a big int, which came from, if you want to use Unix timestamps for things like nlock time, you're able to do it like this. So math.round date.now by 1,000 plus 60, so you're saying in 60 seconds, 1 minute timeout, and then you have a big int for your timeout. And then we got a coin flip instance, and here now we have everything we need, right? So on line 69 of all numbers, we're now actually constructing an instance of the contract. So you say new coin flip instance, and you just pass everything in, right? And as long as you pass everything with the right type, then you can actually construct it. And you can hover over it. You can see all the things that you need to pass in and what we're passing, and then you have it, right? So you constructed an instance. You can only do this after the JSON has been hydrated, right? And then it'll hydrate that template that's in the JSON under the hood and do some magic. And then there's your offer script. So we now created an instance of an output script using the coinflip instance. You just say coinflip instance.locking_script.toHex, and then there's your hex script. So then create action, off it goes, stuff it in the basket on 78, and let everyone else know, right? So now it's like, okay, we're set to like broadcast, blah blah blah. Here's a description, and then let's let Bob know, hey, I just challenged. And then we're ready, right? So that's how you create an instance of an sCrypt contract using this way of doing it.
Nice.
And then it goes on chain, right?
Okay.
So, questions at this point?
Yep.
Before we move on.
No, I think it's okay. We've then got to go and see how it's unlocked, don't we? Is that what we do next?
We what now?
Oh, don't we want to see how it's actually unlocked? Did you actually show the whole contract?
No, I'm going to do that next.
Yeah, that's what I thought. Okay.
So,
Preempting you.
Contracts have, I talked about annotations. We have the decorators. We have one for prop, and we have one for method. That's the other one. So the constructor is obviously a constructor. What is it?
Are those the only two decorators?
Those are the ones that I've used so far.
Good. You don't know the ones, right?
I don't believe there are other ones that I know of. But those are the ones you need to get started. Obviously, this creates a locking script, right? That's going to be used to actually, put on chain how you unlock it. And obviously, these methods are ways to unlock the contract. So you provide different public methods. And these are all valid, right? These are all ways to unlock the contract, as long as you can make all the assertions true, right? Your goal when you unlock the contract is to pass in the required amount of parameters to make all of the assertions be true. And if you do that, then you win. You get to unlock the coin. So it's like by the time you get to the end of this file, think of it like, or by the time you get to the end of this function, it's like you're setting up an obstacle course for yourself. And if you dodge all the obstacles, then you win. And by the time you get to the end, if you win, you just get all the money. You get to unlock the output. Mm-hmm. That's basically what every method in a contract has. And these are all different ways to do it. So there's 1, 2, 3, 4, 5 ways four ways, because this one isn't really a public. So to denote a way to unlock it, you set up a public function. So all these start with public, and those are the methods that unlock the contract. And then you have a private method, which you can do things like state transformations and private methods, etc. But that's different, and I'll get to that probably later or next time.
Okay.
So every public method is a way to unlock the contract?
Every public method, yeah, and you can create private methods that are not a way to unlock the contract. But every public one, anybody could call any public method. Like, think of it, not only is it public for you, but it's on the blockchain. So it's like public in the most public sense of the word. It's public for the entire world. People will try to call your method and pass in anything they could possibly pass in order to unlock this contract.
Yeah.
And if they do, they will get all of your money.
Yeah.
So code like that, right? The code very strictly, because if they manage to get through all of the obstacles that you set up with your assertions, they will win and they will take all the money.
Yeah.
And they will laugh in your face if you...
the $2, yeah.
Right. or the $200 million.
Yes, yes. Okay.
Right? No pressure. Right?
No. Right. When you set up a contract, do you just use a constructor, or can you also use methods when you're setting it up?
No, you must only use constructor. Right. And in the constructor, you must only write assertions, which are just for cosmetic purposes. They're not real assertions. They're just, can you make the script or not? Will the code throw an error or not? And then you just assign your variables. That's all you can do with the constructor.
Okay.
Maybe you could put this in a function, but no. I don't want people to use methods in a constructor. That would be way too complicated.
Yeah.
Now we can get into a little bit more of the meat and potatoes of the rules of the limitations we're subject to, right? So every public method must end with an assertion. It must contain at least one assertion. You are not allowed to use loops, or if you do use a loop, your loop must be it must have a condition that can be evaluated at compile time, not at runtime.
Mm-hmm.
And your iterator must happen at the loop has to be evaluatable at compile time, basically. You're very, very limited in for loops or anything like that. I believe your I is less than, like say for I equals 0, I is less than 5, I plus plus. 5 cannot be a parameter that you passed in when you are unlocking your contract. So basically loops are very difficult. You can't use loops. There are no while loops. If you say while true, sorry, can't work.
Yep.
Not going to compile. Because think about what it's doing under the hood. It has to unroll all of your loops into a predicate that has no loops.
Yep.
So So at compile time, it has to literally take that and repeat that same code over and over again and paste it into the script over and over again.
Yeah.
You know how many times to paste it in the script. So loops are very limited. I wouldn't use them if you can avoid it.
Yep.
You can use if statements. That's fine, right? If is fine. You can use, in fact, I use an if statement in this contract. I'll show you later. There's one. You should put all of your assertions in the method body. You should not put assertions in or outside of the public method itself. You should also not call any, I would really avoid calling any other method inside of your public method.
What if it's a helper method?
You probably want to, I mean, you can have helpers, but they're subject to the same limitations. All of the types that you pass around need to be definite types. You must explicitly declare all types. You cannot declare variables that are not constant and known at the time of compilation in your function. There are no variables. You can't say let x equals, y. You can't even say, what I tried to do is one time I said, let x, and I said, if y equals z, then x equals z, otherwise x equals a, right? It's like you can't declare variables. You can declare variables as long as they are, you can make member variables, like stateful variables in your contract, like at the class level. You can add them up here, right, at the top. But you cannot conditionally assign variables. So it's actually better just to duplicate code, surprisingly.
Yeah.
Just paste the same code in multiple places if you have to do that. I had to do that once in the contract. I'll get to that. So variables can only be declared if their value is known at compile time. Types must be explicit. I think I covered that. And those are the main things. Obviously, no imports of any library in this file. You will completely. It will have a stroke. You cannot import authorite. You cannot make HTTP requests. There are no promises.
No.
Don't use promise syntax in here.
Why does VS Code underline arguments? Isn't that a known word?
Well, the linter probably doesn't know about it because it's an old thing in JavaScript from the 90s, but you can still use it.
Yeah.
Use the rest parameters.
Yeah, but what it wants you to do is say ... rest, which means everything after the ones that were explicitly declared. But I don't want to do that. I want all of them.
You want all of them, yeah.
Yeah. So just linter yelling at me, but doesn't want me to do it. Anyways, yeah, those are the main rules. You'll probably definitely try something that won't work. You can't use strings. There's no strings.
Oh.
You have to use bytes.
Right.
No strings. You can pass strings in as assertion failures like this.
Yeah.
But there's no actual strings. Like text, you can't say let x equals hello world. No. Only byte strings, which you can convert from UTF-8. You can use the 2-byte string function to actually create a byte string. But you can't use just normal strings. No integers. You have to use big int. I think I said that already.
Yeah.
No booleans, apparently. Every type you use must be imported from sCrypt TS, or must be derived in some way from types that are only imported from sCrypt TS. You can do data structures, but the structures must comprise types that are base types from sCrypt TS. And I have not used data structures yet. I have not had a reason to. And this is a pretty complicated contract, so I don't think you'll have a reason to use them for a while. If you do eventually, look at Xiaowei's thing. But yeah, so now we can talk about the first method that I'm creating here. So the @method thing is a decorator. You have to decorate all your methods, even if they're non-public methods. Like if they're just helpers or state incrementers, as I'll get to down here, still have to annotate them with method. If you don't, there will be a problem. So the only exception is the constructor, which is a constructor. So that's why it's exempt. The method decorator takes in a optional sighash type, and takes a few other things as well, but I've only used a sighash type. So the first thing that it takes is a sighash type, and if you don't provide this, it will be sighash all, meaning all inputs and all outputs must be signed. So here I'm saying that anyone can pay none, meaning the signature over this that we're passing in using this sig, as well as the one must be of that type, right? So don't you will get failing check sig errors if you try to sign with a different sig hash type than what you pass in here, and I learned that over the course of many hours. So take that knowledge and don't find it out for yourself.
So the at method decorator, is that the only param or whatever that it can take? Is the sig hash flag?
I know the first param is a sig hash flag. I have not had occasion to use any other params, but I've never really seen contracts that use that. I don't think there's much of a need, but maybe there's other things. You know, if you hover over it, you can see any of these types. Shoei has been good about providing types.
Nice.
So it looks like you can pass in a sig hash type, which is optional, which is a sig hash type or undefined, and then it returns, a target, which is any method name, string, description. So that's like all internal compiler stuff, right? Property descriptor, whatever. But that's what you pass in. It looks like only a sig hash type. There's no other options.
Okay. So you're saying none in that context?
Yeah. Sig hash type. So are we familiar with sig hash types in Bitcoin?
Yes, but I've probably gotten rusty on some of them.
Yeah, beginning to.
All right. There are 6 sig hash types in Bitcoin across a few different things. You have the combination of, for outputs, you can say all, single, or none. Those are your 3 options for you're talking about outputs that you're signing. And then you multiply 3 by 2, because you're saying there's 2 combinations for inputs. So inputs, you have anyone can pay, or you have not anyone can pay, right?
Those are for inputs?
Yeah. So think of a table in your head in which there are two rows and 3 columns, right? The rows represent the possible combinations for inputs, meaning there are 2 combinations for inputs, and then there are 3 combinations for outputs. So you have 6 possibilities, right? So you can combine anyone with you can say anyone can pay is true or false on any of the 3 things for outputs. You can say anyone can pay none, anyone can pay single,
yeah.
Anyone can pay all.
Yeah.
You can say not anyone can pay none.
None, yeah, not anyone
not
can
anyone
pay.
can pay single. And then not anyone can pay all.
Okay.
And when you say not anyone can pay all, that's the default. Like if you don't provide one, it will just be that no one else can pay, and all outputs must be. So those are the 6 possible combinations of sig hash flags. I'm not going to talk about fork ID because it's always set and it's not relevant. It doesn't change anything.
Yeah. Not anyone can pay. That's saying, is that over any inputs or no?
That's over any inputs, meaning if you say not anyone can pay, means that you're including all of your inputs in your signature, meaning no other inputs can be added.
Okay. Anyone can pay is someone else could add another input. The signature is still valid?
Right, correct.
Okay.
Yep, that's what anyone can pay does. It's either can other people pay or no. Have I signed all the inputs that I'm going to use, or have I not?
Okay. So is it in that, is it like the prefix of that is for inputs and the postfix or whatever is outputs?
No, like if I just say all, like if I do sighash dot, I can see here's my options, right?
Okay.
Does anyone can pay all, none, and single, as I said, and you got all, none, and single with no anyone. Okay, so it's either anyone can pay underscore, meaning anyone can pay is enabled, and then or not having an underscore, not having it there at all, right? So you stipulate anyone can pay if you want it. Otherwise, it's just all, none, or single. right?
And those relate to the outputs, the all, none, or single.
Yeah, all, none, or single relates to outputs. What outputs are signed?
Yeah. Okay.